All right, strategy for solving exponential equations. So the first thing is isolate the exponential term. So that means to get it by itself. Try to get the bases the same on both sides of the equation and set the powers equal to each other. So that's doing what we learned before, where if you can get them written as the same base on either side, then all you have to do is set the exponents equal to each other and solve. That's what we did in the exponential section. It was much simpler to do things that way and cleaner. But if in most cases, you're not going to be able to write both sides as the same base. So if you can't, then there's two different options that you can choose, and whichever one you feel the most comfortable with. I usually always do this first option, which is to take the logarithm of both sides and solve for x by using the power rule for logarithms. So that power rule says if you have something to a power, you can move that power in front as a factor. Or you can change to logarithmic form or change to logarithm form and solve for x. You may have to use the change of base formula to do it this way. So again, I usually always do that first bullet point, and that's what I'll be modeling here for you. So first one, solve 8 to the x equals 16. So that first step said to isolate the exponential piece, and that's isolated by itself, so that's already done. Then step 2 says to see if you can write these as the same base. So 8 and 16, I can write both of those in terms of base 2. 8 is the same thing as 2 cubed, and that's all to the x power. And then 16 is the same thing as 2 to the 4th. So then I'll use properties of exponents. 2 to the 3x equals 2 to the 4. Now I have these written in terms of the same base on either side, so I can just set the exponents equal to each other. And I get that x equals 4/3. I'll leave the check up to you, but luckily with exponentials equations, we learn that the domain of an exponential function is all real numbers. Okay, let's do another one. 19 plus 5x equals 13. So in this case, I don't have the exponential piece isolated, so I need to get it isolated. First thing that I'm going to do is I'm going to subtract 19 from both sides. When I do that, I'm left with 5 to the x power equals 33 minus 19, which is 14. Now I have that exponential piece isolated. Step 2 said to see if you can write them as the same base. You can't, unfortunately. 14 is not. There's no power of 5 to any power that gives you 14. That's an integer. So unfortunately, we can't do that. So now I'm moving on where I have to pick one of those two options. So again, I usually always use that first bullet point where you take the logarithm to both sides and use the power rule. So once you have the exponential piece isolated, take the logarithms of both sides. Now remember, with an equation, as long as whatever you do to one side, you do the same thing to the other side, it keeps the equation balanced. So this is completely legal mathematically to do. And the reason that I wanted to do that is because I can use that power rule, which allows me to get that x now out of the exponent and write it as a factor in front of the logarithm. Which is great because these are just numbers. They're just nasty numbers, but they are just numbers. So to get this x by itself, right now this x is getting multiplied by this number log of 5. So to undo that, we'll divide both sides by log of 5. And I get that x equals the log of 14 divided by the log of 5. Now what you're going to see in this class in your homework and both on the exam is sometimes you're asked to find the exact answer, which this would be the exact answer. So that's before putting it into technology and simplifying. Other times you're going to be asked to find the approximate answer. So approximating is going to be putting this into your calculator or Desmos or whatever technology you're using to approximate what the solution is. So when you do put this into your calculator, the log of 14 divided by the log of 5, you'll get that it's approximately 1.64.